a Soviet engineer tried to build a machine. There was neither a ship nor a plane, and it actually worked until politics, weather, and reality killed it. The Caspian Sea, 1966. American spy satellites photographed something impossible. A massive shape, bigger than any aircraft ever built, moving across the water at 400 kilometers an hour. The CIA gave it a name, the Caspian Sea Monster. They had no idea what they were looking at. For years, Western intelligence treated it as a mystery, a secret weapon, something the Soviets had built that defied every known category of military engineering. The reality was stranger than the speculation. It was the product of one man's obsession, a design that actually worked, and a program that collapsed not because of enemy action, but because of Soviet bureaucracy, saltwater corrosion, and the simple fact that the ocean does not cooperate with things that try to fly just above it. Before the monster, there was a hydrofoil. Rostislav Alexeyev was already a respected engineer by the time he started thinking about ground effect. He had spent years perfecting hydrofoils for the Soviet Navy, vessels that lifted their hulls clear of the water as speed increased, reducing drag and allowing them to outrun conventional boats. Hydrofoils worked. They were practical. They were already in service, but they had a hard limit built into the physics of water itself. When a hydrofoil moves fast enough, the water pressure around the blade drops so low that it begins to boil. Cavitation. Tiny bubbles form, collapse, and erode the metal surface. It destroys performance, damages the foil, and imposes a speed ceiling that no amount of engineering can push past. Alexeyev understood this better than anyone. So he decided to stop fighting the water entirely. He would bypass it. His insight was simple once you heard it. A wing flying close to the ground generates more lift and less drag than a wing flying high. The air becomes trapped beneath the wing, creating a cushion of pressure. Ground effect. Pilots had known about it for years. It was why planes floated during landing. Alexeyev wanted to build a vehicle that lived in that cushion permanently. Not a plane. Planes need altitude to be useful, and the altitude kills the effect, not a boat. Boats live in the water, and water drag is what he was trying to escape, something in between. Something that would skim just above the surface, using ground effect as a permanent substitute for both wings and hulls. The Soviets were interested because speed matters in warfare. A ship that could move at aircraft speeds, operate in shallow water, and approach hostile shores at low altitude would be difficult to detect by radar, sonar, or visual patrol. It could bypass mines, avoid submarines, and land troops, or cargo anywhere with a flat beach and calm water. From a military planner's perspective, it was almost too good to be true. The project was classified from the start. Alexeyev's team worked in isolation, building progressively larger prototypes in secret, refining the design without outside interference. The world would not learn about any of it until the satellite spotted the first operational model. The KM, short for Corable Maquette, meaning ship model, was the giant, over 90 meters long, wingspan wider than a Boeing 747, powered by 10 engines mounted high above the fuselage to keep saltwater spray out of the intakes. Takeoff weight exceeding 500 tons. It was built in a shipyard, not an aircraft factory, because it was officially a ship, but it flew with the posture and feel of a plane. On its first test run, it lifted off the water at just over 300 kilometers per hour and stayed low, riding the air cushion between its wings and the surface of the Caspian. It turned, it accelerated, it landed, and it did all of it without behaving like any vessel the Soviets had ever built. The KM proved the concept at scale. Alexeyev had shown that the idea could work. But it was not a practical machine. Pilots trained for it found that control was more demanding than flying a fighter or piloting a ship. The ground effect cushion shifted constantly with the weight of the vehicle and the condition of the water. A slight movement of the controls could send the KM dipping into a wave or climbing too high. The turning radius was measured in kilometers, not meters, meaning that sudden course corrections were impossible. Visibility from the cockpit was poor, forcing pilots to rely on instruments and judgment in ways that were exhausting over longer patrols. The engines were another problem. Jet engines suck in whatever is in front of them. When you fly 6 meters above salt water, what is in front of you is salt spray, seabirds, and occasionally debris. The turbines corroded faster than any comparable aircraft engine, requiring constant maintenance and frequent replacement. The cost of keeping a single machine operational was astronomical, even by military standards. Weather was the worst of it. The KM was built for calm seas. In the Caspian, where the waves rarely grew beyond a meter in height, it could fly safely. In the open ocean, where swells were unpredictable and storms could rise in hours, the margin for error disappeared entirely. Rough seas were a major limitation. A wave tall enough to touch the fuselage at speed would be catastrophic. The Soviet military understood the limits quickly. The KM was too large to deploy practically, too expensive to operate routinely, and too fragile for the conditions it would actually face in a real war. Interest shifted towards smaller designs, like the Orleanok and later the Lund class, hoping that scale could solve the problems of cost and handling. It did not. The smaller machines were easier to operate, but the fundamental compromises remained. They were still too expensive, still too weather-dependent, and still too limited in range to justify the investment. By the time the Soviet Union began to collapse, support for the program had already faded. Brezhnev's leadership had never been as enthusiastic as Khrushchev's. The military budget was strained by submarines, missiles, and a conventional navy that actually worked. Alexeyev's dream was increasingly viewed as a distraction, a pet project that consumed resources without delivering strategic value. He died in 1980, not long after suffering a stroke. His team continued the work for a few more years, but without his advocacy and with the state's attention elsewhere, the program lost momentum. The KM was abandoned, left to rot at a dock in the Caspian, its wings removed, its hulk half submerged, until salvage teams finally scrapped it years later. The Lund class, the one that looked like a missile barge with wings, was completed and briefly operational. It flew. It proved the design, and then it was parked. Russia could not afford to maintain it. The facilities needed to keep the engines running, and the hull intact no longer existed. It sits today, the last complete Ekranoplan, parked on a beach in Dagestan. A Cold War machine built to carry 6 devastating anti-ship missiles, now serving as a strange backdrop for tourists, taking beach selfies, most of them completely uncertain of the monster they are looking at. The West's fascination never really disappeared. The Caspian Sea monster became a legend not because it was effective, but because it was strange. It looked like the future in 1966, and even now it looks like something from the edge of science fiction. But the reality is more human. Alexeyev was not a madman. He was a skilled engineer who solved a real problem, built a working machine, and could not convince anyone to keep paying for it. And yet, the idea never quite died. Decades later, the US military attempted to resurrect the concept with the Liberty Lifter, a massive ground effect transport designed to leap across the Pacific. The physics Alexeyev harnessed still worked perfectly, but history repeated itself. The project was quietly cancelled after nearly $98 million in investment, brought down by the exact same identity crisis that plagued the Soviets, a machine forever trapped between the laws of the sea and the rules of the sky. Maritime manufacturing regulations and aviation certification standards couldn't agree on what the vehicle actually was. The problem was never the concept. Ground effect works. The physics are real. The machines flew. The failure was not in the engineering, but in the circumstances surrounding it. Weather, corrosion, bureaucracy, and priorities that shifted faster than the design could mature. There is a strange dignity in that. The Ekranoplan was never a hoax. It was never a fantasy. It was a legitimate attempt to create a new category of transport, a genuine third option between the airplane and the ship. It failed because the real world is harder than the blueprint, and because the people who might have kept it alive eventually decided it was not worth the fight. Half plane, half ship, fully abandoned.